Okay, in this video, I'm going to address this question. You have a wire that is 32 centimeters long. You wish to cut it into two pieces. One piece will be bent into the shape of a square. The other piece will be bent in the shape of a circle. Let A represent the total area of both the square and circle. What is the circumference of the circle when A is a minimum? Okay, so let's just kind of sketch out what's going on here. We have this wire, kind of giving it distinct endpoints, and we're told it's 32 centimeters long. All right, and we're going to cut this wire into two pieces. So here, I'll just pretend those are the two pieces, okay? One piece, I'll go ahead and just call it X for right now. And the other piece is whatever's left over from the 32 centimeters. So the best way to write that is 32 minus X. Okay, we're going to fold these two pieces into two different shapes. So one shape is a square and the other is a circle. I'm going to focus on the circle really quick because they're asking about the circle. So if I took this little piece of wire here that I cut into two pieces, this piece right here, and I bent it into a circle, this is what I'd have, all right? And since this length is X, what's just happened here is I've formed the circumference of the circle. And the circumference of the circle is X. Now with the other piece, I'm going to go ahead and fold it into a square. Make a little square out of it. All right. Now for this one, the outside area or the perimeter is 32 minus X. Oops, perimeter is not spelled with an E at the end. All right. 32 minus X. Now because this is a square, that means that all of these sides are equal. All right. We've learned that, which means that if I take 32 and divide it by 4, that's going to give me the length of a side. So one side is going to be 32 minus X over 4. All right, now they ask for the total area of the circle and the square. So let's start by finding the area of the circle. So the circle, to find the area, it's pi r squared. Now the problem is I don't know what r is. I do, however, know the circumference. So I'm going to use the circumference to help me find this area. So I'm going to go ahead and put that on hold. And I know that the formula for the circumference is 2 pi r. And I'm going to use this to solve for r. So now I have an expression for r in terms of x. So the radius of this particular circle is x over 2 pi. Okay. And now I can find the area of the circle, pi r squared, by plugging that in for r. So I'm calling it area 1, by the way, since there's two areas to find. So it's going to be pi times x over 2 pi squared. Or another way of writing that would be pi times x squared over 4 pi squared, which is actually kind of nifty because now I can reduce the 2 pi's. So these 2 pi's will cancel, and I'm left with x squared over 4 pi. Now that is the area of the circle. Okay, now I want to do the same thing. I want to find the area of the square. And the reason I'm doing this is because they told us we're finding the total area. All right, so the area of a rectangle or square is just length times width. And in this particular problem, since length and width are equal, since we're looking at a square, it's just going to be 32 minus x over 4, which is the length of one side, and times it by 32 minus x over 4. All right. So what we're going to do is we're going to multiply out, or another way of saying this is we have 32 minus x squared. I'm going to FOIL that, all over 16. Okay, so to multiply out 32 minus x squared is to do 32 times 32, which is 1,024, minus 32x twice, which comes out to 64x. And then multiplying the x's gives me x squared. You can work that out slowly if you need to. Now, for right now, I'm going to go ahead and leave this formula with the fraction. It's possible to reduce it, but I am going to divide each piece. Oops, that's a 6 over 16x, and that's 1/16 x squared. I'm just going to go ahead and leave them all over 16. All right, so these two areas combined together to give me a total area, which is what they're trying to look at. All right. So combining these two areas together, let's shift this up a little bit. X squared over 4 pi plus 1024 over 16, 64 over 16, 1/16 x squared. Okay, so I'm going to go ahead and, oops, sorry, 16. I'm going to go ahead and take a moment and reduce to see if I can divide. And the reason I'm not so stressed about that is because even if I couldn't divide, I can continue with the problem. So if your number that they give you in your problem isn't 32 centimeters, if it's like an odd number, you don't have to worry. You can just keep working with the fraction. But this does reduce down to 64. And then 64 divided by 16 is going to be 4. Unfortunately, though, I can't reduce the x squared. I do notice, though, that the very first term I'm working with has an x squared in it as well, right? So I'm going to rewrite this first term as 1 over 4 pi x squared so that I can see that both of these terms have an x squared in them, all right? And the reason is I'm going to combine them together. I'm going to join them together as one term. So if I were to add these two up, basically I would add the 1/4 with the pi plus 1/16. I'd add those two together, and that would give me the term in front of the x squared. And then I'm going to put, the next term, which is 4x plus 64. So I'm putting it in standard form. I'm writing it with the x squared term first, and then the b term second, and the last is the c term. The reason I'm doing that is I'm trying to get us to notice that what we're really staring at here is a quadratic equation. Okay, and if I know anything about quadratic equations, I know visually they're parabolas. They look like U shapes. Okay, and when a is a positive number, that means that it's an upward facing parabola. Well, this number, if I plug into the calculator, is going to come out positive. It's going to be a decimal, but it's going to be positive, which means I'm looking at a right side up parabola. Now I'm bringing that up because they gave us one clue up here in the problem as to, what we're supposed to do. And it says, what is the circumference of the circle when A, the area, is a minimum? They're wanting us to find a minimum. That word is cluing us into the process that they're asking us to do. So because they told us it's a minimum, I'm curious about when this parabola has a minimum value. And that occurs right here. There is the minimum value. And I happen to know the name of that. It's the vertex. So in essence, they're asking me to figure out the vertex of this. I have a formula for finding the vertex. It's x equals negative b over 2a. That tells me the x coordinate of the vertex. So I'm going to go ahead and plug into this formula my b value, which is negative 4, over 2 times my a value, 4 pi plus 1/16. All right. And I'm going to plug that into the calculator. I'm going to be very careful to make sure to put parentheses around the numerator and the denominator. And the idea is that when we plug this in, I did notice these are both positive, so I'm not going to bother plugging the negative in. I'm just going to put 4 divided by 2 times 1 over 4 pi plus 1 over 16. And I'm going to be very careful to use parentheses around the 4 pi also. All right, plus 1 over 16. Close that. All right. And I am getting 14.07683 if I round it to 5 decimal places, which should work as an answer to the problem. You can go to about 5 decimal places and that would be fine. Now, this is actually the answer to the question. So I found x, which happened to be the x coordinate of the vertex, but x also happened to be the circumference, which is what they were actually wanting me to find. What is the circumference of the circle when a is a minimum? So I'm done.